The Singleton pattern should be used when you want to make sure that only one instance of a class can be created. There might be times when you want to make it impossible to create multiple instances of a class, while still making sure that there is a way to access that one instance. So in what situation would you need to do this? Some typical examples include window managers, database connectors, file managers, user interface dialogues, and resource accessors and spoolers. Say, for example, that you have a class that controls access to a resource like a printer. You might have multiple printers, but you would want to make absolutely sure that only one instance of the class that controls access to them could be created. If there were multiple print spoolers, they might try and allow two different processes access to the printer at the same time. Or say you had a logging class that needs to be used repeatedly by all the files in your project. Again, you would want to make sure that there was only one instance of that logging class. Having multiple instances might cause your program to give incorrect results, behave strangely, or crash. The solution to this problem is to use the Singleton pattern, so that only one instance of the print spooler or the logging class could be created. There are some examples of the Singleton pattern in the Java API, for example the desktop class, the system class, and the runtime class. Every Java application has one and only one instance of runtime, which can be accessed with the public method getRuntime. The Singleton pattern is perceived as one of the simpler creational design patterns, and it is fairly straightforward to understand the concept. But it shouldn't be overused. If you find that you have lots of examples of the Singleton pattern in your code, it might be a better option to refactor. However, it is a well-known pattern and an important concept to understand, and there are many situations when it comes in useful. Here is a public class called printSpooler that implements the Singleton pattern. The printSpooler class has a private static field called spooler, which is of type printSpooler. This is the one and only instance of the printSpooler class. There is another private static field, which is called initialized. This is a Boolean flag to mark if the object has been initialized. Before the first printSpooler object is created, this flag is set to false. The most important part of the printSpooler class is the private constructor. Having a private constructor prevents code from any other class creating new printSpooler objects. The only place to create printSpooler objects is from within the printSpooler class itself. This way, the constructor is only called once. In this example, that happens when the instance variable is initialized. Note that initialization of the object is also separated out in a private method called init. In this example, the method is empty to keep the example simple, but in a more complex program, the code to initialize the printSpooler objects would go here. The initialization is separated out because for the Singleton pattern to work, it must be impossible to get a reference to the object in an uninitialized state. The program needs a global point of access to the one printSpooler object, so that it can be used in other classes. This is done with the public method getInstance. First, the method checks if the object has already been initialized. If it has, and the flag is set to true, it will return that instance. If it hasn't been initialized, a new printSpooler object will be created and then initialized by calling the init method. Then the flag will be set to true, and the new instance is returned. If the method is called a second time, the initialized flag will have been set to true and will return the first instance. It is now impossible to create a second instance of the printSpooler class. And it is just as simple to get this instance from another class. If I open up the Resource Manager class, I can create a variable called spooler. Normally, when I create a new variable, I just use the Java keyword new, but when I try and do that with my Resource Manager class, an error shows up, telling me that the printSpooler constructor has private access. Instead, I should call the getInstance method. This will create a new instance of printSpooler, initialize it, and set the initialized flag to true. So if I call this method again, it will return the instance it already created. Problems can occur when using the Singleton pattern in a multi-threaded program. Java supports concurrency, which means multiple units of execution can run at the same time. If a program has multiple threads that are using the printSpooler class, it is possible for two different objects to be created. In this example, the Resource Manager class has two threads running at the same time. Thread 1 is started, and right afterwards thread 2 is also started. Both threads call the getInstance method of the printSpooler class. Thread 1 calls the method first. The first line of the getInstance method checks if the initialized flag is set to true or false. As this is the first time the printSpooler class has been used in the program, this is set to false, so the thread carries on to the second line, where it creates a new printSpooler object. It then enters the code to initialize the object. At this time, the second thread might call the getInstance method. Again, the first thing that happens when the method begins is a check to see if the initialized flag is set to true. The first thread is still inside the init method. It hasn't yet set the initialized flag to true, so the second thread also goes to the second line and creates a printSpooler object. Now there are two printSpoolers. This seems like quite a complicated problem to solve, but actually it is very easy to stop this from happening. The only change that is needed is to make the getInstance method synchronized. Synchronized is a Java keyword that restricts access to the code inside the method. If the program was run again now that getInstance is a synchronized method, the problem would be fixed. Thread 1 would enter the getInstance method, and it would be locked until it had finished. Thread 2 would not be able to enter that code until the spooler object had been created, and the initialized flag had been set to true. One drawback to bear in mind when using synchronized methods is that they can slow the program down. This is because threads are having to wait for other threads to finish methods first. There is a further way to improve this printSpooler class. Instead of creating the spooler object inside the getInstance method, it can be created when the field is first declared. Then we can also make the field final. This way, even if the getInstance method was not synchronized, it would still be impossible to create two spoolers. This is because the spooler object would already have been created before the getInstance method was called. However, the getInstance method still needs to be synchronized to protect against the init method being called twice. In general discussions of the Singleton pattern, it is sometimes advised that it is better to keep the object creation inside the getInstance method. This is because creating an object as soon as the class is loaded is an example of eager initialization. It has been created before it is certain that it will be needed. Keeping it inside the getInstance method would mean that the spooler object was only created when it was definitely going to be used. This is known as lazy initialization. However, in Java, this is not an issue because Java already uses lazy loading. It is unlikely the printSpooler class will be loaded in the JVM unless the getInstance method is called, so there is no problem with moving the creation of the spooler out of getInstance.